Our team name, Sheikah Tower, is inspired by the iconic Nintendo game Zelda. In this game, the hero, Link, activates a central tower called Sheikah Tower to access a map that holds information about the area. On this map, the information is both remarkably detailed and safeguarded for privacy. Link is both the information consumer and contributor of the map, and the map is trusted by everyone who uses it. In many ways, our journey echoes Link's first interaction with the map. We are driven by a humble desire to explore the immense potential of MEC and edge computing for large language models applications. We are building an ecosystem. We aim to provide the necessary infrastructure while leveraging the advantages of MEC. This involves optimizing data consumption, enhancing security and privacy, addressing the challenges between cloud, edge, and end users, and achieving improved redundancy and resilience. We're also leveraging the wealth of additional information offered by MECs and synergizing it with large language models to enhance the overall user experience. In essence, we aim to open up a map similar to Link's for other developers and end users, serving as an example of how MEC can be a valuable resource in creating solutions that improve the lives of everyday people. Join us on this exciting journey to create a reliable ecosystem with MEC access and leverage the power of edge computing for large language models applications. We've employed a hardware and software co-design approach. On the device side, we seamlessly integrate various user data types, including live information, location data, and inputs in multiple formats, such as images, text, audio, JSON, and video saved in vector database. These inputs undergo embedding searches for relevant information and are then processed within our Flow client before being transmitted to the MEC as inputs. The MEC side is where the real magic happens. We leverage MEC, API, and local vector databases, each housing data in diverse formats. These rich local data, along with the user inputs from the device side, empower our large language models with user-specific insights and abundant local knowledge. We prioritize user privacy by obfuscating private data, including location and photos, with generic prompts before transmitting to the cloud or LLM model. We are also facilitating seamless streaming audio interactions through our streaming ASR/TTS services, which operate on the MEC. Lastly, on the edge computing front, we are striving to maximize the potential of edge resources, including computing, storage, and server engines, which opens up opportunities in the future such as federated learning on the edge. This approach enables us to deliver highly customized and localized services, ultimately shaping the future of our platform. Now let's look at our demo. This is the user database interaction in the demo. The blue circle represents the user, and the red circles represent the databases accessible in the same cell ID and zone ID. When the user enters a new zone, the local databases appear and connect automatically. This interaction enhances user experience through localized agents, comprising localized databases and prompts. It enhances security by limiting database access to when the user enters the area and ensures low latency with ample computing resources, loading only nearby data for efficient access. Now the user starts to explore the city. Every second, the live location is retrieved and the user is able to see the abundant local databases around him. Let's ask a simple question to kick off the conversation. Please note that we replaced Monaco on the map with Hyrule, a name from Zelda, and introduced non-real database info to highlight that it originates from our local database, not just LLM. Using the user's current location, interests, and nearby databases, the LLM generates personalized recommendations for exploring the secret Egyptian museum. Again, that this museum and its database were added by us and do not exist in Monaco. Now, As we've entered the Egyptian museum, the museum's assistant recommends exhibits that might capture the user's unique interest from the user database. It goes beyond what the LLM can naturally generate from its native database, providing additional information and insights. The database can handle multiple formats rather than text such as images. For example, this user found this statue in the museum very interesting. The user took a picture and wanted to chat with the agent about it. The localized agent allows interactive conversation as it knows so much about the user and the place, or exhibit in this case, in a safe way. In this case, the LLM chats with the user, asking the user questions as an old friend. This example shows how the neighborhood can benefit from the MEC ecosystem. The user has wrapped up the museum tour and soon feels exhausted. The user keeps walking and wants our assistant to find him or her a place to stay for the night. With the hotel's database updated by the hotel owners, our assistant can identify the nearest hotel based on the user's preference and provide guidance with the latest updates. In this scenario, both the hotel and the museum share the same cell IDs and zone ID and utilize a common MEC base station and edge computing resources. In practice, when the first museum establishes its database and computing power, the neighborhood can also benefit by setting up similar infrastructure and sharing resources. This not only enhances efficiency, but also fosters trust within the MEC community. This is the end of our demo. Thank you.